হ্যালো।
ঠিক আছে স্যার বলছি এখানে চ্যাট বসানো কিছু মেসেজ দেবে লাইভ হয়ে গেছে এখন এখান থেকে আপনি ঠিক আছে ঠিক আছে হ্যাঁ ঠিক আছে শুধু মেসেজ করবে
ও ছবি কিছু নেই?
না ছবি কিছু থাকবে না স্যার ওই চ্যাট বক্সে ওরা যা চ্যাট করবে ওই মেসেজ আসবে
ঠিক আছে। হ্যালো, তোরা চলে যা, তাহলে আমি চলে যাচ্ছি আলাদা। হ্যাঁ, তোর বাবাকে ওখানে না না হ্যাঁ না
লাইভ হয়েছে না এত ইয়ে হয়ে গেছে স্যার পাবে
ওরা কি আমাকে দেখতে পাবে?
হ্যাঁ স্যার যদি কেউ ইয়ে করে অনলাইনে চলে আসে এটা যেহেতু স্যার 2টার দিকে চালু হওয়ার কথা ছিল
আরে আমাকে 2:30 বলেছিল তো।
আমাদের 2টা থেকে বলেছে রেডি করে রাখতে
আমাকে 2:30 বলেছিল, আমি তো ওই জন্য 2:30 এসেছি, 2:30 আসছিলাম আর কি। আসলে একটু বাড়িতে সমস্যা হয়ে গেছে, বাবার শরীর খারাপ হয়ে গেছে ওই জন্য। Hello, if there are any doubts in the ML-1, you may please ask. অন্য সেশনগুলো ডাউট এসেছিল 4টা?
না স্যার ওটা হলে ওখানে সুব্রতর ওখান থেকে হয়েছে এখানে শুধু আপনার এটাই রেখেছিল
তোমরা কি শুধু এটার জন্য এলে, আর কিছু ছিল না?
না আজকে আর তো কিছু ছিল
এ বাবা, আমি ভাবলাম এখানে ছাত্ররা আসবে কিনা। কালকে এক্সাম, কালকে তো আসতে হবে নাকি? থাকতে হবে। খেয়েছে তো দুপুরে?
Yes.
আজকে এখানে আরেকটা কি মিটিং ছিল না?
হ্যাঁ স্যার, নিচে একটা মিটিং চলছে। কতদিন চলবে এটা? না, না কোনো কোশ্চেন করে দেখছি কিছু না। না স্যার এই যে টাইপ করেছিল কিছু ML-1 হ্যাঁ কোশ্চেন নেই।
তুমি সুব্রতার লিঙ্কটাই অন করলে তাই তো?
কোথায় দেখাচ্ছ না তো? হ্যাঁ, এই তো স্যারের সামনে যেটা তুমি টিম করে তো কানেক্ট হয়েছে, দেখো একবার।
ওকে কিছু টাইপ করতে বলো না।
না হ্যাঁ সব ইয়ে করছে, টিম ভিউয়ারে কানেক্ট হয়েছে।
কি ইউটিউব লিঙ্কে দেবে বলছে?
হ্যাঁ স্যার ইউটিউব লিঙ্ক পাঠিয়ে দিয়েছে, ওই লিঙ্কটাতেই হচ্ছে মনে হচ্ছে।
হ্যাঁ ডাউট দিচ্ছে নাকি?
না দেখছে জানো সব টিমে কানেক্ট হয়েছে। না স্কেপ মারবো।
কি ইউটিউব লিংকে দেখা যাবে বলছো তো? কোন লিংক?
বার করছে নিজে।
ML-1
এই কোশ্চেন।
ও এইগুলো?
হ্যাঁ স্যার, এই যে এইখানে লেখালেখি রয়েছে। ঠিক আছে। হুম। আচ্ছা, এইখান থেকে লিখতে হবে। পাশেও রয়েছে।
এখান থেকে নাকি?
হ্যাঁ, এগুলো হচ্ছে কোশ্চেন রয়েছে, আপনি এখানে।
কোথায় কোশ্চেন রয়েছে?
এই
এইগুলো তাই তো?
হ্যাঁ স্যার। হ্যাঁ স্যার, লেখা আছে। সেট করুন।
যাচ্ছে কিছু? হ্যালো?
কথা শুনতে হবে, মেসেজটা যাবে।
No, so let me cover one by one. So the first thing is that the syllabus is exactly whatever is covered in the lectures, nothing more. So if I have not covered Gini, it is not there. So in the syllabus, it is only the entropy, not the Gini index. Is only the entropy and not the Gini index. Okay, so wait, let me read the questions then answer it. Maybe that will be better. So the first question is, can you use pandas for assignment? Answer again, of course, people have answered yes, you can, except scikit-learn, you can use anything else. Sorry for the delay in the quiz. Actually, there was a mismatch in the timing, so I was thinking it from some other time. There was a confusion regarding that. All right. So the next question is, can you share the answers for quiz 1? I think the answers are already shared. In Moodle, there is some hidden assignment issue. I'll maybe look at the setup again. So we'll talk to our Moodle team, look at the setup and correct this henceforth. This question, the scope of the exam is only what was taught. Yes, it is only what was taught, nothing else, nothing less. Assignment 2 is extended to 13th. So I don't know. I mean, if most of the people want it 13th, we can always put it on 13th. That's not the issue. So what I want is that you can discuss among yourselves in the forum. If you feel 13th is a date, or let me extend it till 13th. No harm in that. So let me extend it till 13th. We have time for putting out the marks after that. So the deadline for assignment 2 is 13th, midnight. In the M estimate, it is explained that what is the value of P. P is not a probability. P is an parameter which you can choose any value between 2 to anything. So you can choose a value. P is a parameter. P decides the amount of smoothing you want to do. So you can have a very large amount of smoothing, or you can have a very low amount of smoothing. So P decides the amount of smoothing you have. It's a parameter. It's not the probability or anything. Then in the M estimate, P, A, J given C, it is the class conditional probability, of course. This is the probability of attribute J taking on value A, taking on value J given class C. Okay, so what entropy is? I think you should go through the definition in the slides. What entropy is? It is the, I think it is clear that if N1 example some class 1 and N2 example some class 2, it is N1 by N1 plus N2 into log of N1 by N1 plus N2 minus of that, and again minus of plus minus of N2 by N1 plus N2 into log of N2 by N1 plus N2. I think this is fairly well explained in the slides. If you go through the slides one more, I think there will be no problem in understanding this. It's fairly straightforward. The M estimate concept is in the slides from ML-1 in the Bayesian, naive Bayes part, Bayesian statistics part. So Sandeep Rao, I think these I have already answered. We'll extend assignment 2 till 13th. Okay, so the difference between condensed nearest neighbor and KDT. Condensed nearest neighbor, what it does, the set of examples, the training set on which, against which you compute the nearest neighbor, that is reduced. Only the points near the class boundaries are kept in the training set, rest of the points are dropped. So this reduces the number of points against which you compare a new point, find out the nearest neighbors. Whereas KDT keeps all the points, every entire training set it keeps, but it uses an indexing structure to quickly search through this all the points by comparing few attributes as we go down the route. Okay, what do you understand by the solution of the entropy formula? No, it's not a solution of the entropy formula. Entropy is, suppose you have a collection of points of which n1 belong to class 1, n2 belongs to class 2, you can compute this entropy. Now the question is, does the division, so if you divide the data sets into 2 points, this n1 will be subdivided, n2 will be subdivided. After subdivision, each of the partitions, again you compute the entropy, and you add up these two entropies of the 2 partitions, and you have the parent partition from which again you calculate the entropy. Information gain is the reduction in entropy because of this partition. That means original entropy minus the sum of these 2 entropies. The significance of entropy, it helps you get better class homogeneousness. You get more homogeneous classes if you split an entropy. Exactly. So KD tree is an interval tree. It's a data structure, whereas condensed condensed nearest neighbor is reduced number of points. Distance weighted KNN. Normal KNN, what you do, you take a point, computes its distance with all training set, find the k closest point. And in the distance weighted thing, so and then after you find the k closest point, you see what is the majority class, which class has the highest representation in this k, you put it in that class. Distance weighted, you don't take just a voting, majority voting. What you take, the weight of each neighbor in the vote is proportional to the distance of the neighbor from the point to be classified, and then you take a vote. So for example, the plus class is more close than the minus class, so plus class will get more vote. So that's the weighted nearest neighbor. Anything else? Anything? No. Oh, yeah. So Pavan, it is okay now. I'm getting this. I was logged into a different Hangout account, so I was not seeing any chat window. Any other question unanswered, you may please type. Exactly. Condensing is to reduce the data points. So if you remember the slides, the in condensing you keep only the points in the neighborhood, in the bound, near the boundary. So if you take a union of the the Voronoi diagrams, the class boundary remain unchanged even if you drop the interior point. So that's what condensing does. The purpose is to reduce the computation. Suppose there are 1000 points, you have to find distance to each of these 1000 points to find out the nearest neighbor. Whereas in the condense, if you condense it to 100 points, you only need to compute distance to 100 points. So that's the reduction. Yes. So high dimensional data, the problem with Euclidean distance is that if you have very high dimension, then if in any of the dimension there is a big difference, it will override the other dimension. So that Euclidean, so the ranking of the points with respect to their distance has less and less meaning in higher dimension. So you get sparse. So for example, let me give a simple example. So if you take 2 dimension and keep a 1 radius circle, and you can get and you put say k equal to 10 inside a 1 radius circle, you get a certain density. Now you go to 3 dimension and may have a 1 radius hypersphere. Okay, so take a 1 radius hypersphere and you put 10 points inside it, the density reduces. You go even higher, you go to 4 dimensions and you still have a unit radius, whatever, circle or hypersphere or whatever, and you put 10 points in it, the density even reduces. So higher dimension you go, the sparser and sparser the points become. So if you take the distance, so keeping the k constant, the distance of the kth neighbor is much less in 2 dimension than in say 100 dimension. Is there any condition where the logistic regression classifier cannot be used? No, unless, I mean, of course, if the class distribution is very complex, if the class boundary is complex, you cannot use it. It has to have a simple structure. Second is, if you have a multi-class case, you cannot use a single logistic regression, you have to use multiple. Okay, so these are the kind of examples where you cannot use logistic regression. I hope it has answered. Otherwise, you can ask again. Okay, so let me explain entropy. So suppose I have a set of 200 points, of which 150 are from class 1, 50 are from class 2. So the probability of class 1 is 150 by 200. The probability of class 2 is 50 by 200. So 0.75 and 0.25. So entropy of this entire collection is minus 0.75 log of 0.75 minus 2.25 log of 0.25. This is the entropy of the entire collection. Now suppose I split these points into 2 parts, each containing say 100 points each. And the first 100 points have 60 from one class and 40 from another class. And the other 100 set of points have 90 from one class and 10 from another class. So the probabilities are now 0.6, 0.1 in the first half and 0.9, 0.6, 0.4 in the first half, 0.9, 0.1 in the second class. Individually, you can compute their entropy. Individually, it is minus 0.9 log of 0.9 minus 0.1 log of 0.1. And on the other half is minus 0.6 log of 0.6 minus 0.4 log of 0.4. So the total entropy of this split part is the sum of their individual part entropies, which is sum of this quantity minus 0.9 log of 0.9 minus sum of these two quantities is the entropy of the sum. And their parent had an entropy of that 0.25 log of 0.25 minus 0.75 log of 0.75. So this was the entropy of the parent, and then you can calculate the sum of the entropy of its child. Information gain is sum of the entropy of the parent minus the sum of the entropy of the child, or rather the entropy of the parent minus the sum of entropy of the child. This is the reduction in entropy you get by the splitting. And the reduction in entropy is nothing but the gain in information gain. So we choose an attribute splitting on which would lead to the highest information gain as defined in this manner. Thank you. Okay, so there are two indices, Gini index and entropy. Usually there is no clear-cut theory to say in where Gini is better or where entropy is better. The thumb rule is that if you have large number of classes instead of 2 class, maybe if you have say 100 classes, 100 different classes, then Gini index performs better. So because of the entropy, you know that what entropy does is that it for each of the class, so n1 by n1 plus n2, n2 by n1 plus. So if you split too many things, then entropy is not good. Then Gini is better. Similarly, if any attribute has a lot of values, say attribute is binary 2 valued, entropy is better. Suppose the attribute has 100 different values it can take, then again Gini is better. Okay, so that is the thumb rule. Again, that is a thumb rule because what is large number of classes is an undefined thing. So yeah, so the questions will not be on code snippets. They will be like, suppose I give you a, like the example I walked in the slide. Suppose I give you a small table of some attribute value and their class levels. You have to apply the naive-Bayes classifier, and then if I give you a new example, you have to compute what is the output of the naive-Bayes classifier for that new example. So these kind of simple things. Am I in? Okay, so I think that's all. So if there are any more questions, please raise in the forum. Please raise in the forum that I can then answer all of them. The exams will be easy, no doubt. Thank you.
হয়ে গেছে স্যার। ঠিক আছে, তাহলে আমরা এটা বন্ধ করে দিচ্ছি এখন। হ্যাঁ, আর কালকে সকাল কটার সময়? ঠিক ঠিক আছে, কেনা বন্ধ। ঠিক আছে,
ঠিক আছে। জল আছে?
তোর একটা জল আছে?
একটা জল আছে?
সব জল নিয়ে দিচ্ছি, কিছু হয়ে গেছে। ঠিক আছে।